All right, so I gave everybody a review last class, right? Try and take a look at that. We're gonna review today, so I don't have. You know what? Yeah, I might have. Do you have just a regular pencil? I have a regular one that you can. Yeah, here, you can have that one too. Okay, so in terms of the review, before we start going over the review, I wanted to add a problem to the review that I forgot to put on there. So there's a problem. Remember this formula I've given you, d of t equals negative 16 t squared plus v naught t plus d naught. Remember that? This was for falling objects on Earth. You remember that? Yes?
Yes.
Okay. I forgot to put it on the review. I apologize. So when I was going back and looking at the review, it's like, I know there's something else we did, and so this was it. So let's make this number 11 on the review. I'm just going to do an example, all right? We've done these before in class. So here's the example I'm going to do. This one's a little bit tricky, all right? A helicopter is rising at 26 feet per second when it is 400 feet high. It drops. Let's make it a bag. I was going to make it a bomb, but we'll try and be nice today. It drops a bag. All right. Here are the questions. Find a function which describes the position of the bag in terms of time. This problem is going to seem confusing initially, but then once I explain it, I hope it'll make more sense. So first thing we're going to do is find a function which somehow tells us where the bag's going to be at every point in time. Then I want to know what is the maximum height of the bag. And I want to know when does it hit the ground. All right. I'll give you a moment to copy that down. Where is everybody? Okay, got it? So think about the situation here. You have a helicopter, right? And you've got a bag. And the helicopter, this is my helicopter, is rising, right, at a certain rate, 26 feet per second. And then it's going to drop this bag. So we're going to find a function which describes the position of the bag. But this second question, what is the maximum height of the bag? Do you think, it drops, when it is 400 feet high, it drops the bag. What do y'all think? Do you think 400 feet is the maximum height of the bag then? What do you think? I'm seeing a lot of nods, yes. So think about it though. The helicopter's moving up, isn't it? So when it releases the bag, you would think, okay, from 400 feet, it's just going to fall. Like, so if the helicopter was just hovering right here at 400 feet, and I dropped the bag, then of course the maximum height of the bag was 400 feet, right? But if the helicopter's moving up and then releases the bag, watch what happens. Just watch the pen. I'm going to kind of exaggerate it here. It's hard to see. I can go a little faster. Do you see how the bag kind of came up and then went back down?
Kind of like almost levitates.
Yeah, I mean, it's going to go up a little bit, then come back. See, because the bag is moving up as well, isn't it? At 26 feet per second. So this is almost like throwing a rock off of a 400-foot bridge, but throwing it up into the air at 26 feet per second first. Does that make sense to you? So the maximum height of the bag is not going to be 400 feet. It's going to be a little bit more than that because it's going to go up just a little bit. Let me do it one more time. I'm going to exaggerate it really, really bad this time. Okay, see, I let it go. It went up and then came back down. Okay, so we are going to use, and I'm going to need my calculator here. I'm going to use this one. We're going to need to use the formula. And remember, on the exam, on the review I gave you, for this exam, I will allow you to have a reference sheet, right? 1 8.5 by 11 sheet of paper, front and back. Any steps or procedures or formulas that you think you're going to need for the exam. I would definitely have that on there. I'm not going to provide that to you. Okay, this will not be given to you. So we're going to use this formula, and we just have to remember what the important numbers here are. V naught is something in D naught. So do y'all remember what's what here? What V naught is in D naught? D, think D distance, okay? This is your starting height. Oops, starting height. This is your starting, gosh, can't spell. Starting speed or velocity. Now, I told you about the starting speed. There's something about that number. It will be positive if you're going up. So this is positive if up and negative if down. And we actually have never done a problem in this class where we had it going down, but you could say, you know, think about a person standing on a bridge and throwing a rock downward. If I told you, hey, you're going to throw the rock downward at a certain velocity, you would use a negative number there. Okay, so for us, our formula will be, this part A, d of t will be negative 16t squared. That will never change. That will always be the same in all these problems. And then my plus v naught. Now v naught is the starting speed, positive if up, negative if down. So what's that going to be for us? Plus 26 t, right? T plus, okay, the starting height. So where did we release the bag from? 400 feet. This is your quadratic function that gives you the position of the bag at every point in time. Okay? So that's part A. Part B, find, what is the maximum height of the bag? So if that's a quadratic function, right, which opens down because it's got a negative, right, then it's going to have a highest point. And that's what we want to find. That was what, though? What do we call the highest point on a parabola? The vertex, right? And there was an h and a k. The h always told us which, you know, this left and right, and the k always told us the up and the down, right? So part B is really asking us for what part of the vertex? H is left and right, k is up and down, and we want to know the maximum height, right? So we really want k from the vertex. That's what that question's asking us for. Understand? But to get k, we have to get h. All right, so I'm going to start off here by getting h. There was a formula for that, negative b over 2a. That was our formula for h. And that means you need to figure out what a, b, and c are here. So Negative 16 is A, positive 26 is B, and positive 400 is C. So I'm going to come in here and fill this in. This is going to become negative 26 over 2 times negative 16, which is negative 26 over 32, negative 32, sorry. And then I'm going to have to use my calculator to get a decimal here. I get H is equal to 0.8125. Okay? So I want to just draw a quick little picture for you right here to kind of explain to you again what's going on. This is T, this is time, this is D, that's the height of the ball, the bag. When we start, when the helicopter lets go of the bag, at that instant that it lets go, the bag is 400 feet high. But it's going to go up a little bit and then back down. So as time goes on, the bag goes up and then it comes back down, hits the ground. We are trying to find this point, HK, right? We're trying to find the K, which would tell us how high it is. We just found H, right? So can somebody interpret what this H means? 0.8125, what does that mean? That's not how high it went, right? Isn't that this direction? Well, what does the left and right represent? T, right, which is time. So time, this is how much time it takes for it to reach that maximum height, right? So the helicopter lets go of the bag. The helicopter keeps moving up, right? The bag comes up a little bit and then starts to fall, right? The time it takes for it to go up and hit the top of its path, right? It takes 0.8125 seconds to actually reach the maximum height. And then it's going to start to fall. Now, I'm not asking for that in this question, am I? I'm not asking for how long did it take to reach its maximum height. I'm saying what was its maximum height. I just want you to kind of think about what that number means. It's how much time it took for it to go up. Now to get K, what we have to do is we have to take this value and plug it into the function. So since our function is called d of t, I'm going to put d of 0.8125, which means I'm going to do negative 16 times 0.8125 squared plus 26 times 0.8125 plus 400. So just plugging 0.8125 into that function, and then make sure you just use the proper order of operations here. So I'm going to have to square that first, so 0.8125 squared. So this is negative 16. When I square that, I get 0.660. Let's just go with that. And then plus, let me go ahead and multiply those two together. So 0.8125 times 26 gives me 21.125 and then plus 400. I'm going to go ahead and multiply those two together. Negative 16 times 0.66, that's it. So I get negative 10.56 plus 21.125 plus 400, and I'll add all that together. Are there any questions while I'm doing this? $410.5, I'll round it, 0.57. 410.57 feet, right? So the answer to part B is 410.57 feet. I'm not going to be real particular about how you round that. If you want to say 410.6, that's fine. If you want to go more decimal places, that's fine. I don't care. So that means when the helicopter released the bag actually went up another almost 10.5 feet and then started to come down. Got it? Have you ever done this? I know I used to do this with my daughter a lot. Have you ever rode an elevator and you go and you try and time it where when you come to the top, whatever floor you're going to stop at, you try and time it where you jump? Have you ever done that before? No, you're missing out on life. Okay, you know, like elevators that are really fast, these on our campus are real slow, but if you get into a really fast elevator, when you get to the top, you can kind of feel that little ooh, you know? No? If you time it where the elevator, right when it stops, you jump, you'll actually feel like you jumped higher than you've ever jumped before, because you're like the bag in the helicopter. You're going up, the elevator stops. If you jump at that moment, you're going to have your jump, like the speed that you normally would get with a jump, along with the elevator kind of throwing you up at the same time. It's, yeah, I guess those are the fun things we used to do before phones. And then on the opposite is if you do it when you go down and time it to where you get to the bottom, when you jump at the bottom, you'll jump and then you'll go like that, because the ground, you're going down and the ground stops, but your bodies really want to go down. So if you jump, the ground comes up towards you a little faster. Anyway, all right. Okay, so we're done with part B. Part C. So what is part C saying? Well, we found that highest point, right? We found this 410.57 right there. We found that. Part C is saying, when does it hit the ground, right? When? T, right? Time. We want to solve for T. T is this, right? Left and right. So hitting the ground would correspond to this point right here, which means we want to know what that distance is. That's an X-intercept, right? That's what we've normally looked at parabolas where it hits the X-axis. It's an X-intercept. So we want to find the X-intercept of this function. Now, we should technically call it a T-intercept because the variable is T, but it's the same process. To find the X-intercept of a quadratic, you set the function equal to 0, right? That's what we do. So I'm going to set that equal to 0 for part C, and whatever I get is going to be, well, how long it took for the bag to hit the ground. Are y'all upset that I'm putting this problem on the test? I'm sorry. Okay, so for part C, we're just going to take negative 16t squared plus 26t plus 400. We're going to set it equal to 0. Now, when this is a quadratic equation, and we have two options. We can try and factor, which I can almost guarantee you, for any problem that I give you that involves something being thrown into the air or something like that, it's not going to be factorable, which means you're going to need the quadratic formula. So there's another formula you need to make sure you have on your reference sheet, and that's this one. Remember, it said if you are given a quadratic equation, then the solutions to this are negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Okay, that's our quadratic formula. That's how we solve any quadratic equation, right? So we're going to use that same formula, but instead of having x's, we have t's, right? So I'm going to say here, all right, from the quadratic formula, t must be equal to, first thing here, negative b. So b is 26, so negative 26 plus or minus the square root of, okay, we need to square b, right? That's the next thing. So you'll take 26 and square it. 676 minus 4 times a was negative 16, times c, which was 400. All of that divided by 2 times a, which is negative 16. Do y'all remember what I said when you're using this formula about figuring out this part? This is the part that causes most people issues. Do you remember what I said? If I have an even number of negative signs, then I'm going to add the number, right? So I have one subtraction, two subtractions. Two subtractions, that's an even number of minuses. So what I'm going to do is I'm going to leave the 676 alone. I'm going to multiply these three numbers together, and I'm going to make sure I add that number. So negative 26 plus or minus the square root of 676. And then I know it's going to be a plus. And then I multiply this number, and this number. I don't even care about the signs. I'm just going to do 4 times 16 times 400. It's a big number. 25,600. Then all over negative 32. That's what you get when you multiply 2 times negative 16. Go ahead and add these two numbers together. Okay, add those two numbers together and then take the square root. And I'm just going to tell you what you get. Okay, so this should be equal to negative 26 plus or minus. So after I add those two numbers and then do the square root on my calculator, I get 162.1. I'll just round it to one decimal place. Actually at 162.0987. I'll just go 162.1. All divided by negative 32. Okay? Questions? Questions? This is where I do two different things. First, I'm going to do the plus, okay? So on my calculator, I'm going to do negative 26 plus 162.1. That gives me 136.1. Now I divide that by negative 32. So make sure you do it in that order. You first have to add them together, hit enter, then hit divide by negative 32. And you should get negative, wait a minute, hold on. Negative, yeah, this is right. Negative 4.3, I'm rounding it. Negative 4.3. Then I do negative 26 and I take away 162.1. That gives me negative 188.1. And I divide that by negative 32. Negative divided by negative should be positive. I get let's say 5.9. Okay. So what's my answer then? I have two answers. When does it hit the ground? It's the 5.9. It's not the negative, because the negative is a negative time, and we're going to throw that answer out. The way I told you to look at this back when we were doing this initially is that, see, the quadratic function actually comes... This one's dead. I'm feeling lucky today. It's off. Oh, it's off. Just leave it. I'll get it. Okay, so this parabola actually comes backwards this way and hits over here, if we were to draw the whole parabola. But because this is a bag being dropped out of a plane, I'm only looking at when time is positive. Where'd it go? Oh, there it is. Okay. All right, so my answer is 5.9 what? Seconds. All right. Questions? All right. That's it. Now I could give you that problem, with a bag and a helicopter. I could just say, a rock is thrown off a bridge. I mean, I'm not going to deviate too much from that. If during the test you're not sure about the question, you can just ask me. All right? Okay, now in terms of the review, I gave you 10 questions, right, to practice. And I know you spent a lot of time, hey, how's it going? You spent a lot of time doing that, so I anticipated you would have some questions over it. No questions. Did y'all do it?
Yes.
Try it at least. Which one do you want me to talk about? Your test will not be as long as the review was in terms of, it's not, I don't think I'll give you 10 questions.
Do the rational ones?
You want to do the rational functions? Okay, which one? 4, 5, or 6?
Maybe 5.
5? Okay. So f of x, can you just read it out to me, please?
F of x equals 3x squared minus 21x over x squared minus x minus 20.
Okay. So the instructions here are to sketch this. We're supposed to use the techniques that we had in class, right? So what is the first step to sketching a rational function?
Find the x-intercepts.
Find the x-intercepts. Is that something you should probably have on your reference sheet? Yes. Find the x-intercepts. You should probably tell yourself how to do it, right? How do you find the x-intercepts? Set the numerator to 0. Okay, so you're just going to look at the numerator. 3x squared minus 21x. Set it equal to 0. Now, when it came to this step, I said you need to know how to factor, and there were basically like three different things I wanted you to be able to factor. 3? No, 4. So you need to know GCF, you need to know any sort of difference of squares, factoring a trinomial, and grouping. Those are the only scenarios that I wanted you to be able to handle. So this one to factor would be GCF, right? Both these terms have something in common. They both have a 3, and they both have at least one x. So I can factor out a 3x, which would leave me with what in the parentheses? X minus 7. Good. And then you set each of those factors equal to 0. So set this equal to 0. Set this equal to 0. The only number you can multiply times 3 to get 0 is 0 itself. You could also divide both sides by 3 there if you'd like, and you still get x is 0. Here you just add 7 to both sides. All right, so we have 2 x-intercepts. The next thing, vertical asymptotes, right? To do that, you set the denominator equal to 0. And the way you do this, again, you could use a quadratic formula here if you wanted to, because it's a quadratic equation. But this is that thing where I said you take the number in front here, multiply it times that number, you get negative 20. The number in the middle here, negative 1. You need two numbers that multiply to be this and add to be this. What are those two numbers? Multiply to be 20, add up to be 5 and 4. One of them has to be negative.
Negative 4.
Negative 4 and positive 5, or negative 5 and positive 4? You need minus 1, right? So it's got to be negative 5 and positive 4. Those are your two numbers.
What I got for.
Oh, okay. Yeah. Gotcha. So once you're here, what you'll do is you'll do set of parentheses equals 0. And remember this little tricky thing with you have to do something with the number in front here? But if it's a 1, you don't have to worry about it. So all you have to do is put x minus 5, x plus 4. And yes, it would be the same if you had these the other way. If you had x plus 4, x minus 5, that would be the same. Set each of those to 0. So if I set that to 0, set that to 0, you get x is 5, you get x is negative 4. Any questions? Are y'all feeling good about this test? Yeah? Okay. Third step, horizontal asymptotes. Right? Horizontal asymptotes. There are 3 different scenarios you could run into. And you need to know how to handle all 3. I think in the review I gave you all 3, didn't I? I gave you 2 of the 3. I don't think on the test I'll give you one that does not have a horizontal. One of the cases, when the degree of the top is bigger than the bottom, that's when you have none. I'm not going to give you that. So you know it's going to be one of the other 2 cases. So in this case, we go and we look at the degrees, right? We say, okay, the degree of the numerator is 2. The degree of the denominator is also 2. When they are the same, you are going to have a horizontal asymptote. And what it will be is, y, in this case, when they're the same numbers, y equals, and then what do I look at?
The leading coefficient.
The leading coefficients. you look at that number, and then you look at the number in front of this one, and you make a fraction out of them. You take the one on top, 3, and divide by the one on the bottom. 3 over 1 is 3, so you will have a horizontal asymptote at y equals 3. All right. Fourth step is to start drawing it. So here's my beginning of my picture. I'm going to start with the x-intercepts. The graph will be in purple, okay? These are dots on the x-axis. So at 0, I have a dot, and at 7, I have a dot. Then I have 2 vertical asymptotes. One at -4. Those are those vertical barriers that force your graph up or down. And another one at 5. Now I have a horizontal asymptote at y equals 3, which means you go up 3 units and then do what? Draw a horizontal line only at the ends, right? A dotted line, but only at the edges. So out here and then out here, all right? Not all the way across. That'll mess you up. Any questions? All right, what's next?
Test point.
Test points, good. How many are we going to have?
One more than the X-intercepts and the vertical asymptotes.
One more than we have this and this together. We ignore the horizontal. So we have 2 verticals, 2 x-intercepts. That's 4. We'll have 5 test points. Was there a question? I thought I heard. Oh, I thought you said y. Okay, I apologize. Okay, so over here to the left of -4, I need any number I want. So what do you want? -5, okay. Again, notice I put an x here and I circle it so I don't confuse it with an x-intercept, okay. I need another one between -4 and that x-intercept, so -2, okay. Something between 0 and 5, you did 1, okay. Something between 5 and 7, 6, right. And then something to the right of 7, 8, 10, you could use whatever you want, 8 or 10. Any number to the right of 7. It's up to you. And then this is the part that really sucks. You've got to take those, each one of them, right, and plug them in to this up here, right? It's life, okay? Do you want me to plug all 5 in and go through all the work, or should I just do 1 or 2 of them? What do you want? Okay, all right, so let me do f of -5. Just to remind you what we're doing, we're going to plug this -5 into that function, so that's 3 times -5 squared minus 21 times -5 all over -5 squared minus -5. So you've got to be really careful with your signs here, right? There's lots of little negatives and things to get messed up. So when we get this, we square that first, we get 25. 3 times 25 is 75. Okay, -21 times -5 is a positive 105, so plus 105. All over, okay, -5 squared is 25, minus 5 is plus 5. Let me say that again. 25 minus 5 is plus 5, so 25 plus 5 is 30. Take away 20, that's 10. And all I care about here is that now that this is positive. It's a positive number. Agreed? The top is positive, the bottom is positive, so positive divided by positive is positive. Now if you wanted to find the actual value, you could, but all I care about is that when I go to -5, I'm going to be above the x-axis. So I'm just going to put a point right here. Now, I'm not going to do these, is that all right? If I don't plug in the other 4 and just tell you what happens? Is that all right? So when you plug in -2 and do the work, you should get a negative number. When you plug in 1, you should get a positive number. When you plug in 6, you should get a negative number. And when you plug in 8, you should get a positive. And I told you, make sure you check each one of those. Don't just find the first one and assume that they just switch from there, right? Like, it won't always be positive, negative, positive, negative, positive. It won't do that. So check each one. So at -2, I have a negative number, so down here somewhere. At 1, I have a positive. At 6, I have a negative. Oh, these are points on the graph. And at 8, I have a positive. I should have been doing these in purple. I'll do them in purple. So I should have had a positive here, negative, positive, negative, positive. I don't care where you put this one, okay? You can put it above or below. Doesn't matter. Where do you want me to put it? Above or below? I don't care. You want to go below? Okay. I'll show you what it would have looked like if you put it above, all right? But let me do this first. So we start out at the far left point now, and we draw the function. So what has to happen to the left? What does it do? Careful. What does this dotted line mean? That's a magnet, right? That pulls our function towards it. So our graph must go towards that horizontal asymptote like this. Now to the right, it's going to hit this barrier and have to go up or down. We can't go down because we don't have any X-intercepts, so it must go up like that. Then you go find the next point that you have on your graph, which is this one. What happens to the left? Try and go to the left. It's going to have to go down, right? Because of the barrier. Can't go up. Have to go down. So I'm going to go down here. Then I'm going to connect to here and connect to here. Try and draw to the right. Hit this barrier and have to go up. Does that make sense, everyone? So now that I kind of have a feeling for what's happening, I'm just going to draw it like this. Then over here, notice these 3 points will come together, won't they? Like this. And then as I go this way, the vertical barrier forces me down. And then I go to the right, I got to flatten out towards that. So it's going to go like this and go down. And then over here, flatten out towards that. There it is. I'm going to show you in blue what someone else could have done that would be slightly different than this picture, but that would still be correct. What if this person put their dot here above, and then maybe right here they said below, and then maybe they put above here, and then here they did way down here, and maybe here they did way up here. Okay, so let's see how their picture would look different. From here to the left has to flatten out. Here to the right still has to go up. Here to the left has to go down, has to connect through here, has to go here, and has to keep going up. So it's going to go like that. Then over here to the left, again, I have to dive down, have to come up through the X-intercept, come up to here, and then come back down. Both of those would get you full credit on the test. Because again, like I said, when we were doing polynomials before rational functions, we don't know how high things go and how low things go. Same with here. We don't really know how high and low things are. We just know that to the left of this, everything is above the x-axis, it flattens out and it goes up. Between here and here, left side goes down, right side goes up. Over here, left is down, and then this eventually flattens out. Does that help? Okay. How are we doing here? I did hit record. Yes, I did. All right. So, what else?
The simple interest questions.
Simple interest? Okay. All right, we'll do number 10. So I'm assuming you have the review. If you make a purchase of 35 $75. You go buy a nice new big flat screen TV, okay? You buy this, but you put it on your Best Buy credit card. That's 17.45% interest rate. The question is, how much would you owe after 5 years? All right, so this is assuming you don't make any payments, which means you would get like late, payment penalties and stuff, but just throwing that aside, if you charge that much on a card that has this high of an interest rate, after 5 years, how much would you owe? Okay? So we have to use the shampoo formula. Again, a formula that I would make sure I have on my sheet. I would make sure that I understand what all these letters represent. So what do we have here? What is this in our formula? What is this number? Is it the A, the P, the R, or the T?
It's the P.
The P, that's your principal. That's what you start with, the starting amount. And then this right here is what in the formula? R. But remember, when we do R, we have to convert that to a decimal. Okay, so this is going to be R, but it'll be 0.1745. Converting a percentage to a decimal, you move the decimal point 2 places to the left. So we have that as our R. And then also, I didn't write it up here, but we want to know how much you're going to owe after 5 years. So since it's 5 years, right, 5 years, this will be T, won't it? And what's E? Is E like a letter like P, R, and T? No, E is that thing on your calculator that you're going to use. All right, so here's what we have. The amount that we will owe at the end is $35.75 times E raised to the 0.1745 times 5. So we will want to do this on our calculator. We want to do that on our calculator right now. And hey, make sure you bring your calculators on Thursday, okay? I'm not going to loan any out. Make sure you have it. Okay, so this is where everyone's calculator is a little different, right? Okay, so E, I'm going to tell you what I get, and hopefully you'll get the same thing. Or does someone want to volunteer what they got? 2.39. E to the 2.3, I'm sorry, no, that's already with the E. I apologize, right? Okay, that's with the E and everything. This is 2.39. Now, I agree, that's if we rounded 2 decimal places. I recommend for these problems to be as accurate as possible, to just go out as many as you can, all right? I'm going to go out 2.39288. Mine keeps going, 5596. I'm just going to stop there. I think 4 or 5 decimal places is good for the accuracy here. Take that number, 2.39288, and multiply it times 3575, and you get your answer. It is 8554.55. Here I'm going to round because this is money. So we only round to the nearest penny. Did y'all get that? Wow, huh? That was a $3,500 TV, and because you didn't pay anything back at that interest rate, you actually owe more than twice what the value of the TV was at the beginning, right? How much is that in interest? Take that number and subtract this number. That's approximately $4,979 that you are going to pay the bank to borrow that money because you didn't want to pay it back. You waited 5 years. Remember I drew that picture of the bank last time, the people who have the money, people who borrow the money? The people who borrow the money always wind up paying back more to the bank than they borrowed. Questions? Anyone have trouble getting the 2.39288?
Yeah, but I figured it out.
You figured it out? Okay. Anyone else? Are you not getting it? What's wrong?
I put in my calculator and I got 2.3717.
Let me see, maybe I typed in something wrong. Hold on. I'll do it again. E to the 0.1745, right? It was 45, times 5, 2.3928. You got 27? Can I see how you typed it? Oh, I see what you did. Okay, so bring your E. This right here is not E times this. It's E raised to this times this. So try that again. Anyone else having any issues with it? I'm going to see what you did. Yeah, and then times 5. There you go. That's it. Yep. Make sure you look at the first beginning of class because I talked about a problem that's not on the review that is going to be on the test. It has to do with an object being thrown in the air. We talked about it a while back. I just don't want you to not know that and then be surprised when the test comes. Okay, this all right? Good. Okay, what else can I go through? 9? Okay, so 9 is a very similar problem, right? It's instead of us borrowing or buying something, we're going to put money into the bank, right? So if you put the same amount of money into a simple interest account at 3.45%, so you put 3,575? Yeah. You're putting that into the bank, and the interest rate is 3.45%. Are we doing it for 5 years again? Yeah, 5 years. Right? It wants to know how much money would be there. So, same formula. A equals PE to the RT. So A will be equal to our principal, 3,575. That's how much money we started with. E raised to the interest rate, converted to a decimal, moved it 2 places, so 0.0345 times t, which is 5. So it's very similar to the previous problem. The only difference is that number right there, right? That's the only difference between number 9 and number 10, is the interest rate's different. And this is you putting money into the bank, so you're going to have more money there at the end, as opposed to you borrowing the money and owing more at the end. So do that on your calculator. Let's see, e to the 0.03 times 5. So this should be 3,575 and then 1.1853. I'll just do that. I'm getting $4,237.45 or so. Have y'all ever seen that movie Office Space?
Yes.
Office Space? So y'all hadn't seen Fight Club, but y'all have seen Office Space? The one where like he takes a bat to the printer out? No? Some of you have seen it? No? Okay. If you look at the calculator here, this number was actually 4237.4475. And so we have to round, right? We have to round. Office Space, that movie, is about these guys that are just fed up with their jobs. And they work in accounting in some company. And what they do is they take this rounding, all this money that's really technically like left over, and they put it into a separate account. And they're like, oh, we'll try and like steal a little bit of this money that's being rounded. And it winds up being like, I don't remember how much, but a ton of money. And they have to burn the building, or someone burns the building down or something. Yeah. Anyway.
Sir,
yes.
on my calculator, I got 1.1882. So
0.1882 for this. Maybe I typed it in wrong. Let me see. I don't have my glasses on, so let me try it again. 0.0345, 45, yes, times 5. Oh yeah, 27. What did I type in? What did I type in? I don't know what I typed in. Okay, yeah, this is a error on my part. This is 1.18827. That's going to change my answer. Does it change it significantly? Not really, but it is not right. 3575. Thank you for bringing that up. Okay, this is 4248.06 or 07. That look more like it? Yeah, okay. I wonder what I typed in. I can't go back on the history on this. Oh, I can. Oh, yes, I can see it. I accidentally did not, I did 0.034. I forgot to put the 5. So I did 0.034 times 5 instead of 0.0345 times 5. All right, so if you put that much money into a simple interest account, leave it there for 5 years, your money will grow from $35.75 to $42.48. But that's 5 years it's been in there, so. Okay. What else? We're doing on time here. Go.
This is how much interest did you earn? Is that?
Oh, did I ask you, how much interest did you earn? Okay, yeah, that's, so how much interest did you earn? All you're gonna do is take this number and subtract that number, okay? And that will tell you how much you earned off your money. So take 42, I forgot about that part of the problem. 42.07, subtract the 35.75. So understand, take this number, subtract that number, and you get $673.70. That's the interest earned. So that's how much the bank paid you to borrow your money. 42, 48.7, God, I did it again, 0.07. I'm having a bad day, 0.07. Maybe this calculator's not taking my keystrokes because it looks like it keeps missing things. This should be 07. Yeah. So when you think about it, remember this situation was exactly the same as the person who borrowed the money, right? Right? You had the same amount. Person bought the TV or something, but it was like 17%, 5 years. How much interest did they have to pay? We did the difference, didn't we? You wound up owing more than double what you bought the TV for, right? It was like $4,000 something dollars.
Last one?
On the previous one, yeah. It was, but I'm saying if you take that number and subtract how much you bought the TV for, $4,000 or $5,000. It was about, I think it was about $4,900, somewhere around there, $4,900, give or take. So the point of this is that the bank borrows this person's money, right, and pays them $673 to borrow their money, but then they loan that money out to somebody else and they wound up making $4,900 off of them. So after they pay this person, they've made a profit, right? The bank has made a profit. Okay, what else?
Can we go over number 3?
Number 3, sketch, yes. So we've got negative 2x to the 6th plus 8. Negative 2x to the 6th plus 18x to the 4th. Yes. This is f of x. You're asked to sketch this, right? So this is a whole other set of steps to do this than the rational functions. So the first step for this, what's the first step for this? Leading coefficient test. Should you have that written down on your reference sheet? Yes. Right? So leading coefficient test, what I do is I look at the power here, right? That's my degree. The degree here is 6. The leading coefficient, which is the number in front of that, is negative 2. And then I have to go look at that table, that chart that I had messed up in class, right? And from that chart, which you should have on your reference sheet, you will determine what happens. What does this graph look like on the edges? If your degree is even and your leading coefficient is negative, down on both sides. Down on both sides. So the left side will go down, the right side will go down, in the middle you don't know. Okay? All right, now the next step is the X-Intercepts. And when we do that, all we have to do is take the function, set it equal to 0. And now, again, here's where your factoring comes into play, right? You need to be able to factor that. And this one is a GCF, right? They both have something in common. What do they both have in common? They both have an x to the fourth, right? Is there a number they both have in common? 2, right? So you can pull out a 2 and an x to the fourth. In class, I recommended that if you have a negative on the first one, that you pull the negative out as well with the 2. So I'm going to pull a negative 2 and an x to the fourth. That is what they both have in common. So I pulled a negative 2 out of this. I pulled 4 of these x's out. So what am I left with here if I pull this out of here? X to what power? X squared. And then if I pull negative 2 from here, that really means, okay, what do I have to multiply negative 2 by to get positive 18? What do I need? What? Negative 2 times what would give me positive 18? Negative 9, so I have minus 9 here. And then I pulled all 4 x's out, didn't I? So that's what I have left in there. X squared minus 9. Which you see that and it should trigger like, oh, I recognize that as difference of squares. Yep, good. So negative 2x to the fourth. Then this turns into x plus 3, x minus 3 equals 0. Now you set each of these equal to 0, right? Each one. What about the negative 2? Do I have to mess with the negative 2 at all? I mean, I know I'm going to set x plus 3 to 0, x minus 3 to 0, but negative 2, do I do anything with it? No, I ignore it because I could always just divide both sides by negative 2 right now, and this would still be 0, and this negative 2 would go away. In other words, if you have a number outside by itself, just ignore it. But it has to be a number by itself. It can't be a number inside like this. So really, I'm just going to ignore that. I'm going to set that to 0. I'm going to set x plus 3 to 0, x minus 3 to 0, and get my answers. So what's the first answer here? What number to the fourth power is 0? 0. Okay. This one, subtract 3 on both sides, negative 3. Here, add 3 to both sides, positive 3. Now what? Multiplicity, very good. Multiplicity, this is that whole bounce cross thing. Remember that? Bounce cross? What do we go look at to figure out if we bounce across these? What are we going to look at here? The factored form right here, and we're going to look at the powers on the factors. That's a 4. So this 0 came from something that had a factor power or multiplicity of 4. And 4 is an even number. Anytime you have an even multiplicity, you will do what there? Bounce. So I'm going to bounce here. This negative 3 came from this factor, which has a 1 up here. 1 is an odd number. Odd means you're going to cross. This 3 came from this factor, which again has a 1, which means I'm going to cross. And now you draw. So you draw your x and y axes. You place your x-intercepts, 0, negative 3, positive 3. I know that the left side goes down and the right side goes down, so I know that from this point over here, it's got to go